And that is my motive. You must understand, because I know this is a very important chapter and a very important time. If you understand celestial sphere and time, then all your problems are solved. So okay, so let's go to the animation once again. We know this is the Earth. There's a North Pole and a South Pole. The compass directions are given on the top left. We have an equator. It's an imaginary line which divides the Earth into two hemispheres, the northern and the southern hemisphere. These are parallels of latitude. The parallels of latitude are parallel to the equator, so they are running around in circles because we are projecting the Earth as a sphere. These are meridians of longitude. These are semi-meridians because what we are showing is North Pole to the South Pole. Similarly, you have on the other side also, going from South Pole to the North Pole. All the meridians are great circles because the plane passes through the center of the Earth. The equator is a great circle, but parallels of latitude are small circles. They are not a great circle. So above the equator is northern latitude, below is southern latitude. 0 degrees longitude is an imaginary line passing through Greenwich Village near London, Greenwich Meridian. Has anyone been to Greenwich near London? Anyone or no? If you get a chance, just out of curiosity, go there. They have drawn something over there called the line. You can stand on the line. Generally, people do. I got a chance once I went. So people take a photograph. The line between 1 foot on the left side, 1 foot on the right. So you're standing on both the hemispheres at one time. So that's an imaginary line over there. So that is a reference point taken 0 degrees. And to the east of that is east longitude. To the left of that is west longitude. Greenwich meridian divides the hemisphere in Earth into two hemispheres again, the eastern hemisphere, the western hemisphere. Both of them start from 0 degrees, go up to 179 east and 179 west. 180, we just write 180 like 0. We don't say east or west. Delight is the difference between the two latitudes, arc of the meridian or angle at the center of the Earth between two parallels of latitude. Read and study all the definitions, gentlemen. I don't need to show you the definitions on the screen because sometimes you get short questions, definitions. Again, D long is the arc of the equinoctial or angle at the pole between two meridians of longitude. So I had given an example of a planetarium. Since none of you had gone there, I leave it to your imagination, but most of you knew that there is a dome on top. Why it was like a dome? Because it is similar to what we see at night. When I see north, south, east, west, for me the distance is the same everywhere. Infinite distance, even above my head. So I can safely say that there is a dome over my head. The stars' bodies may be near you, may be far from you, but we have no means of judging the distance. We as navigators, we are not interested in the distances. We are not astronomers. We do not want to go to those stars and planets, so we are not interested in the distances. We are interested in the direction and the altitude. In which direction it lies and what is the altitude from the horizon. So I paste whatever I can see in the sky onto a far off surface called the celestial sphere, which is of infinite radius. So actually what is happening, the Earth is rotating on its axis and it is also revolving around the Sun. The Sun is stationary. But I also told you that since I am trying to find my position using all the heavenly bodies, and when I look around myself in the sky or anywhere, I see that I am in the center. Do I see myself off center? Something is near, something is far? No. I see I am in the center. When you're out at sea in the ocean, you see the horizon is similar all around you, and you are in the center of the world or universe or whatever you can think. So as far as the celestial navigation goes, even though we saw that there are galaxies and billions of galaxies and everything is moving and turning, and we said for our purpose we will consider that we are in the center of the universe or our whatever. So this is the situation. Now the Earth is in the center. And since the Earth is rotating from west to east, we see all the heavenly bodies rising in the east and setting in the west. So now you see the celestial sphere, the sun is rising in the east, setting in the west. The whole celestial sphere seems to move. Earth is stationary now. Because even when you look around you, do you see the Earth moving? You do not see the Earth moving. So here also the Earth is stopped. And the sun is rising, sun is setting, stars are rising, stars are setting. So far everyone has understood the concept. We are trying to relate to our actual situation, what we see on the ground. Any question, gentlemen, so far? Okay. So now let us try to find a relationship between the Earth and the celestial sphere. We said that we will use the heavenly bodies to find position on the Earth. But I am on the Earth. The heavenly body is in the sky. By looking at the heavenly body, by taking a bearing and altitude of the heavenly body, how can I put my position on the Earth? They are in a different world. I am in a different world. So we try to establish the relationship between the two, between the heavenly bodies and between our Earth. So what is that relationship? Let us see. The Earth is in the center. The celestial sphere is an imaginary sphere of infinite radius. I project whatever imaginary lines I have on the Earth onto the celestial sphere. So my equator, if I project onto the celestial sphere, I get the celestial equator, which we call it equinoctial. So here the equinoctial is also dividing the celestial sphere into two hemispheres, the northern celestial sphere and the southern celestial sphere. Any body which is above the equinoctial in the sky has a north declination. Every body which is south of the equinoctial has a southerly declination. Now this is the sun. If I trace the sun on its annual path, you know from the seasons that the declination of the sun changes from south to north. 23.5 degrees south is the maximum declination. 23.5 north is the maximum northerly declination. But we know that the sun is fixed. Sun is not moving in the center of the solar system. So how does this declination of the sun change? Anyone can give me any idea? We have done it very clearly in the seasons. Anyone?
Because of the tilt of the earth.
By the?
Tilt of the earth.
Tilt of the axis of the earth.
Yes, by the tilt of the axis of the earth. The earth is tilted and pointing to a fixed direction in space. We saw that due to the gyroscopic property. Now when earth is on the left side of the sun, the slant, let us say, is toward the left. The southern hemisphere is facing the sun. And when the earth is on the right side of the sun, then the other side is facing the sun, the other hemisphere. If you want, I can show you some diagram so that you can relate to it right now. Let me figure out something. Do we have seasons somewhere? Utmost. Let me try this one. These are more complicated diagrams, that's why I'm not showing you these. Otherwise, this is also a celestial sphere. Yeah. I can show you in the book also, I think. This one, yeah. Can you see this diagram? Seasons?
Yes, sir.
Okay.
Yes, sir.
So here if you see that red line, the tilt of the axis, if you look at the left position, winter solstice, you will see the North Pole is pointing away from the sun and the South Pole is pointing towards the sun. That means the sun is having south declination because it is pointing directly over Tropic of Capricorn. And if you look at the right position of the Earth, the axis remains pointing to a fixed direction in space. So now you will see the North Pole is pointing toward the sun and the South Pole is pointing away. So here it's maximum north declination shining directly over the Tropic of Cancer, 23.5 degrees north. So this is how the declination of the sun changes. The sun remains where it is, but because the Earth is going around the sun, tilted at an angle, if you have a globe at home or a ball, take a ball, make two dots as the pole, make an equinoctial, draw a line with a marker pen. If you have a, you know that knitting needle, where they knit woolens or a long something, insert that through the ball between the poles and then try to figure out, imagine, turn, twist. Things will be very clear for you. This little hard work you have to do so that you can understand everything better. So there is a time, 21st March and 23rd September, when the sun is moving on the ecliptic. Ecliptic also is an imaginary line when the declination is 0. So I think you have got an idea. Let's go back to our slide. So here the sun is at at the winter solstice, southerly declination. For easy understanding, we keep the Earth upright over here. I can tilt the Earth like in that previous slide, but that might complicate the diagram, so it becomes a little difficult to understand sometimes. So this one, the path of the ecliptic, is tilted to the equinoctial. By how many degrees is this tilted, gentlemen? 23 and a half.
Half degree.
Yeah, that is the exact figure, but generally we call it 23 and a half degrees. Now, when the sun is on this path of its ecliptic, where it intersects the equinoctial on its journey from south to north, that point of intersection is called the first point of iris. First point of iris. Then, when it goes up, it starts northerly declination and goes up to the summer solstice. What is this angle called between, there's no name given here, but summer solstice, first point of iris and equinoctial. What is this angle called, 23 and a half degrees?
Angle of obliquity.
It is called the obliquity of the ecliptic. It is called the obliquity of the ecliptic. The definition would be the angle between the equinoctial and the ecliptic. That is the obliquity of the ecliptic, which is 23 and a half degrees. Now, after the summer solstice, the sun is going down now. The declination is going southerly. It remains north declination up to autumnal equinox. That point where it is intersecting and going south, opposite 180-degree opposite first point of iris, is called the first point of Libra. First point of Libra. And then it comes back to the winter solstice. Now, can you imagine this, at least so much Earth in the center and these two lines? Now I am outside the celestial sphere and looking at the celestial from the side. The equinoctial is in front of me and I am looking directly at the first point of iris. The first point of Libra is behind this, I cannot see, but I have just drawn the figure. Now if I turn the sphere, or let us say I go on the other side of the sphere, what will I see in front of me? I will see first point of Libra. Yes or no? If I go on the other side of the sphere, I will see first point of Libra and this will be behind me. And how will the ecliptic look if I'm standing on the other side? See my cursor, ecliptic will look like this. Yes or no?
Sir.
Yes, sir.
Okay,
Yes,
so
sir.
let me take you back to this one. Because some slides, some people like to do the other way. So they have got, one moment. It was in the previous one. Yeah. Now I'm standing on the other side of the sphere. There's a pole star on top. There's a north celestial pole, celestial equator. Some people like to do it the opposite way. Now here they are showing the ecliptic like this. So if the ecliptic is like this, zero declination, ecliptic, In which case now the winter solstice is on the right side and summer solstice is on the left. So I'm standing on the opposite side of the sphere, no problem. I will just reverse my thinking. First point of Iris is on the other side. First point of Libra is on this side. Anyone has any difficulty in understanding this point, gentlemen? You have to keep your mind flexible. मन को चंचल रखो. इधर से उधर भागो. 3 dimension में. So that is a star which is going around a parallel of declination. That is the declination of the star. Sidereal hour angle. This might be slightly from the different topic that we covered yesterday, but since we are at the diagram, might as well show you. The arc of the equinoctial or angle at the pole between the meridian of first point of Iris and the meridian passing through the star measured. Which direction, gentlemen?
Westerly.
Westerly.
Westerly,
sir.
But here the arrow is pointing towards the east. Is it west or east?
West, sir.
Westerly, sir.
Yes, your
Westerly, sir, opposite
imagination,
hemisphere,
no,
right?
because I'm on the
Opposite
other side of the
side.
sphere now. You understand? I'm on the other side of the sphere.
Yes, sir.
So that is why I did not intentionally pick up this diagram, because I know it might confuse a little more. But at least I want to tell you that there are some numericals later on, maybe not you phase 1, where you have to imagine this way also. You have to be on other side of the globe also. So it was just to give you an idea of the 3-dimensional view. I will leave this one now. We'll go back to our previous slide. So the sun is moving on this path, and it is important for you to understand when it will have a north declination and increasing, when it will have a north declination and decreasing. So from first point of Iris to here, it is north declination and increasing, but from summer solstice to Libra, it is north declination and decreasing. South declination and increasing south, south declination and decreasing south. So gentlemen, all clear so far?
Yes, sir.
Yes,
Yes,
sir.
I would like to hear more answers. Yes, sir. Okay, so parallel of
Yes, sir.
declination, this is declination.
Yes, sir.
Parallel
Yes,
of
sir.
declination, this is the declination. What is declination? Arc of the meridian or angle at the center of the earth, just like definition of latitude. So we have a reference point, Greenwich meridian. Projection of the Greenwich meridian onto the celestial pole. Another celestial meridian passing through the body. A star which is not shown, it will come up in a minute. So Greenwich hour angle, GHS star, arc of the equinoctial or angle at the pole between the meridian of Greenwich and the meridian passing through the body. Geographical position where it enters the earth, slightly magnified diagram over here. So that intersection point is the geographical position. 90 minus declination is the polar distance. Some of you answered very well today. Very good. So now here diagram is showing only this part of the sphere, not the other part. Meridian passing through iris, meridian passing through body. So what will be this angle? SHA, sidereal hour angle measured westwards. So now you see this is our westward, the arrow, green arrow is pointing west. So when I was looking from the other side of the sphere, everything was looking opposite in the previous slide. Understood all of you now?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so this is the declination, the polar distance. We come to some hour angles. You want me to show you this hour angle here or on the board?
On the board, sir.
So on the board.
The few slides I will show you here because on the board also it will be same. The other one I will show you on the board. So let us say now this particular hemisphere, the northern hemisphere of the celestial sphere, if I'm standing somewhere above the north celestial pole, you can see my cursor.
Yes, sir.
If I'm standing above this far off, very high, and then looking down, standing above the north celestial pole and looking down, what will I see? Will I see something like this? The pole in the center and the circle of the earth like this, plan view. Some of you might have done engineering drawing. Plan view is what? When you see from the top. Am I right? The radar screen also uses a plan view, plan position indicator. So you all agree that I will see down like this. Pole in the center, bounded by that circle. What is that circle?
Equinoctial horizon.
Equinoctial, sir.
It is the equinoctial. I cannot see beyond the equinoctial because the earth is curved. So when I'm seeing from here, I will not be able to see beyond this. So my vision is bounded by this equinoctial. So I'm seeing from the top and I'm just seeing a circle. Don't imagine any lines so far. So first we are seeing the circle. From P center, if I draw one line through the meridian of Greenwich, can you toggle between the two? Then I will switch on my camera also. Try to do that today. Let us see how it works. Because I wanted to show you that video also before we go for the break. Can you see the board now?
Yes, sir.
Okay. So if I see from the top of the celestial sphere, I can see this, the pole. Is it okay? Understood? Clear so far?
Yes, sir.
Yes, sir.
Now let us say somewhere here is England and there is London and Greenwich over here. Because this is the equator, equinoctial, and north latitude England, no? So putting it over here is correct or wrong? Am I right or wrong?
Right, sir.
If something is having zero declination, I will put it here. But if something is having 90-degree declination, I will put it here. If something is having 30-40 degree north latitude or declination, I'm right in putting it here, correct? So if I draw a meridian from the pole passing through Greenwich, will it look like this? Yes or no?
Yes, sir.
Yes.
So that is why we call this the Greenwich meridian. On this diagram, equinoctial diagram, all great circles are straight lines. This is the equinoctial diagram. Equinoctial diagram or equinoctial horizon. What is the line opposite to this? 180 degrees, because this is 0 degrees. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now, if there is a star on the celestial sphere, let us say there is a star here which is having 25-degree declination. Where should I put it? Here or here? Here?
Down below. Yes, sir.
Yes, sir.
This is just to explain to you declination. 25-degree declination because this is 0 equinoctial. So it will be somewhere here. So a meridian passing through the body will look like this. A meridian passing through the body will look like this. This is a star. Is this clear to you?
Yes, sir.
You see, Greenwich, London having 40-degree, 45-degree north latitude declination. Star having 25-degree, but that is not the reference point here. We are talking about hour angle. So the meridian will pass through that, and both they are just two lines. I am interested in the hour angle. Hour angle is this. So I am talking about hour angles now. I am not talking of the declinations. So what is this angle? What is this angle?
Green star angle.
GHS star, very good. Definition: arc of the equinoctial or angle at the pole between the meridian of Greenwich and the meridian passing through the body measured westwards. Now let us say there is first point of iris over here. First point of iris. It is at the equinoctial, so I have put the dot over there also. But the meridian passing through iris will also be looking similar, no? Because it's a meridian. Meridian is a line joining from the pole through the point going to the south pole. So now what is this angle? What is that red angle?
GHA iris.
Very good. GHA iris. GHA iris. And what is this angle?
SHA.
SHA star.
SHA star, sir.
SHA star. Very good. SHA star. So yesterday we were trying to work out some relationship. There was a formula, if you remember. I'll write it over here. LHA is equal to GHA plus east minus west long.
Longitude.
Correct. So I
Yes,
can safely say that
Yes, sir.
LHA minus GHA is equal to longitude.
Longitude.
East or west we will see later on. So if I want to find my longitude and I have taken a star site, I need GHA star from the almanac. LHA I will calculate by that formula angle P, practical navigation, we will see that later. for this moment, let us say I need GHA star. I told you all the GHA angles are given in the almanac. Do we have GHA star? We don't have. We have GHA iris. We have GHA iris. So GHA star is what I'm interested to find out. How will I get from here? GHA star, this blue one. Can you tell me? Yesterday we saw this in the slide. GHA star is equal to
GHA Aries plus SHA star.
it was the first example was easy because iris was on this side. Now iris is on that side, so we have a little problem. What was the formula? GHA star is equal to GHA iris plus SHA star. Am I right?
Yes, sir.
So this will turn out to be GHA iris plus SHA star. If it is more than 360, we will minus 360. I can, for easy understanding, I will draw iris on this side so that some of you who are not able to understand this second part first, it will be easy. So let us say I draw iris over here. Then maybe it will be a little easy for you to understand. The red one is GHA iris, blue one is GHA star, and which is the SHA star? Red one is GHA iris, this is GHA star, and which is the SHA star now from where to where? Is it this?
Yes, sir.
Yes.
It is this one, no?
Yes, sir.
Yes?
Yes.
Yes, sir.
So if I want the blue angle, what should I do? GHA star is equal to, are we getting it right or no? Or there is still confusion? I can change the diagram a little bit more for you. I can make it a little more simpler for you. Great. Because once you get the simple one, then you can think about the difficult one. So let us say we will make the star here. I think then it will be easy to understand. Star, and we will make iris over here. So this becomes GHA iris. Okay. This becomes GHA star. And this becomes SHA star. Anyone has any doubt on this one, or this is correct? Greenwich to iris is GHA iris. Greenwich to star is GHA star. Iris to star is SHA star. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. So my intention is to find GHS star. By this formula, we can see GHS star is equal to GHA Aries plus SHA star. When we do the numericals, we will do those opposite side ones. Then it will become easy for you to understand. So as far as the formula is concerned, let us follow this simple one. This one is clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we have this formula now. There is another formula about LHA that I will do after the break. And there is a small video also about 3-4 minutes on the celestial sphere, which I will start first with that one and then we will do the LHA. So we still have 2 minutes. Anyone has any question on this diagram, please tell me. No one? I hope all of you are able to understand. Does anyone have a problem with my English, or you want some words in Hindi, things like that? Because I'm not sure if everyone is, because sometimes there are some students, who are not very comfortable with Hindi also. So it's a little difficult to judge for me when you are not there in front of me. So you must always tell me so that I can help you. Any questions, gentlemen?
No.
Okay, take your break, come back after 15 minutes, and then we'll continue.
Okay, sir.
Thank you, sir.